So in last video, we showed we can use the least mean square method to update the weight in the output layer. And be more specific, we can use the steepest descent method to update the weight. So here, the W211 n plus 1 equal to W211 n and plus delta Wn. So here n is the current weight. This is the current weight, and this is the updated weight. And here is the how much adjustment we need to add into the current weight. And in previous video, we showed here's minus the eta, but that's the table. We should use the eta multiplied with the epsilon as the derivative of the cost function respect to W211. So here's positive sign, not the negative sign. I make a correction. Sorry for that. And look at here. We can apply the steepest descent method to update the weight. Here, the delta W comes from two parts. One is the eta. This one to adjust to determine the size, or the adjustment size. Adjustment. So how much adjustment we need to add. This part, the derivative, determine the direction. So which means if either the current weight is too large or current weight is too small, this one can determine which direction they are going to adjust, either make it smaller or make it bigger. And eta determine how much adjustment we need add to the current weight. And epsilon 1, this one is the cost function. We define as 1 over 2 and E1 square n. So this is the equation we are going to use to adjust the synaptic weight. So here, the eta is some constant value. We can determine this by our experience. We'll talk about this later. Another important factor is the derivative of this part. The cost function and derivative according to respect to W211. So equal to this guy. And in order to find this one, we can apply the chain rule of calculus. This one equal to derivative of epsilon 1 to E1 and E1 respect to Y21. Y21 respect to V21 and V21 respect to W21. Okay, go back to this slide. This is in order to apply update this one. So all this component will be used in the adjustment. It's a chain rule of calculus. Everybody on this chain will be used in the adjustment. We got these chain rules. So therefore, if you cancel each of them, this one cancel with this one, this one cancel with this one, this one cancel with this one, you'll get this equation. This is called the chain rules of calculus. We're going to apply this one to figure out what this equal to. So the goal to solve this. This is our goal. Okay, let's start from the first one. The epsilon 1 respect to the E1. Let's start from this one first. So here, since the E1 n equal to 1 over 2 E1 square n, this is the cost function. So if we do the derivative for this one respect to E1, that is nothing but equal to E1. So in the chain rule, the first item is equal to nothing but equal to E1n. We solve this. And now let's move to the second term, the derivative of E1 respect to Y21. So here E1 equal to D1 minus y21n. Let's go back to this slice. You can see here the E1n equal to D1 minus Y21. Let's go to the E1, right? This is what we got from the structure. And go back to this slice. So E1 equal to D1n minus Y21n. Therefore, if we do the derivative for this one respect to Y21, that is the E1n, and then respect to Y21n. This one equal to derivative of D1n respect to Y21n, and the minus Y21n, and derivative respect to Y2, this part. Respect to Y21n. So look at here, the D1n derivative with respect to Y21n, this one equal to 0 because there's nothing in D1 with the Y21 term. And this one equal to minus 1. So therefore, the second term equal to minus 1. This is the second term. Then look at the third term, the Y21n and respect to V21n. So let's go back to this slice. So look at here, the Y21n equal to the activation function of Y21 as the V21n as the input. So this relation is the Y21n equal to the activation function as this one as input. So we know Y21n equal to V21 as the V21n as input. Therefore, if we do the derivative on both sides, respect to V21, this one equal to this guy respect to the V21. So it's nothing but equal to this one respect to V21. So this is the third term. It's nothing but just find the activation function, do the derivative with respect to V21. Therefore, when we define the activation function, there's one condition is the activation function must be differentiable. Otherwise, this one cannot be satisfied. So about the activation function, we know the very popular one is the S-shape functions. It's a single mode functions. So V1 equal to 1 over 1 plus exponential minus AV. So V is the input. So it could be from minus infinity to infinity. But the output will be between these values in this range. So for the activation function, this one, if you do the derivative, that's equal to this function. So the activation function must be differentiable. So that is about the third term. Now let's look at the last term. Last term is the derivative of V21 respect to W211. So go back to this slice. Okay, here we go. So we know the V21 is nothing but the Y11 multiplied with this weight and plus the Y12 multiplied this weight. Summation equal to the V21. Okay, so go back to the last slice here. So here we know the V21 is nothing but equal to the W211 multiplied with 111 plus W221 multiplied with Y21. So what we do is we want this one to do the derivative with respect to W21. So this whole thing over W211N. This one is whole, same. This whole thing is W211N. Look at the second term. In second term, there's nothing in this multiplication. There's nothing about the W211. So therefore, this whole term equal to 0. Look at the first term. This one equal to W211 multiplied with the Y11N. This whole thing do the derivative according to respect to W21. So therefore, this one thing equal to the Y11N. Make sense, guys? So therefore, we get this one. The last term, you do the derivative with respect to W211, that equal to Y11N.